Last episode, we talked about how to choose the insulation material for the flooring. This episode, I will show you the actual procedure how I put my flooring. At the very bottom layer, I put half-inch XPS foam strips, and then on top of that will be 2-inch XPS foam, and then on top is a subfloor with use baltic birch plywood. On top of a subfloor will be hardwood floor or engineered floor or vinyl. As you can see, originally on this vehicle, on the floor, there's these bumps and gaps. This is for the structure of the vehicle floor. If we directly put the XPS board onto these ribs, then will be large gaps between the floor and the XPS board. So my solution is I put these strips of a half-inch XPS to support these gaps. Even the XPS we are using is a 60 psi, but still, over the time, it can be compressed. So these gaps is about 10 millimeter high, and the XPS of a half-inch is about 12 millimeter. So it will be perfect for this application. On top of that will be the 2-inch XPS foam. The hydronic floor heating coils will install in these 2-inch foams. At this step, I noticed the problem. That is, if you install this XPS foam directly on top of the metal surface of the vehicle, it will creating squeaking noise. This noise is very loud, and it's not pleasure to hear. So my solution is to put some vapor barrier plastic sheets on top of the metal surface, and then put the XPS foam on top of the plastic sheet. Then we'll eliminate the squeaking noise. After we put the half-inch strips onto the floor gaps, then we use tapes to secure them to prevent them moving around. Then after that, we put another layer of a vapor barrier. Prepare for the 2-inch XPS foam layer. This layer will be a lot of preparation because this is the core of this flooring system. First of all, we need to draw and cut the grooves for the hydronic heating coils. So when we design these coils and these loops, we have to realize this hydronic heating coil is using the PEX plastic pipes. These PEX has a minimum turning radius. That means you cannot turn them very sharply. But lots of people will design this like lots of 180-degree turns. It will make it very hard on the plastic pipes. So my design is to avoid these 180-degree turns. I'm only use a 90-degree turn, and the turning radius is very large too. So it will reduce the stress when the pipe is turning. So we'll reduce the risk of leaking and reduce the pump's stress. Next step, we need to determine how deep and how wide the grooves we need to cut. XPS is 2-inch thick. The PEX outside diameter is 5/8. And between the foam and the PEX pipe, I want to use our thing called heat transfer plate to increase the efficiency of transferring heat from the glycol to the floor. And as I mentioned before, the maximum working temperature of the XPS foam is a little bit less than the glycol working temperature. So we need to protect the XPS foam as well. So between the XPS foam and the heat transfer plate, I also put a layer of 1/8 thick leather to prevent the foam being overheating. So consider all these factors and measurement. I decide to use the 3/16 router bit to cut the groove. The depth of the groove will be 3/4. This will be perfect. In my original design, I was trying to use those 90-degree PEX bending assistant. But those ones creating another problem is on the edge of the bending assistant is higher than the foam surface. So I also cannot cut deeper, otherwise the PEX will be not in the same level. So finally, I just decide not using those 90-degree bend assistant, and instead I will just make a even larger turn and eliminating the stress of the pipes. So it turns out pretty good. And because I'm not using those 90-degree turn assistant, I can even put more heat transfer plate when it's turning. So it will increase the area for the heat transfer plate. It's even better efficient. This PEX pipe I'm using is called oxygen barrier heating pipes. This is specially designed for the glycol floor heating application. This special treat pipe is specially designed for the glycol, and it won't have a chemical reaction with the glycol. So this you can see these grooves. I was originally trying to use the 90-degree turning assistant, but now I'm not using that. Another problem I'm facing is I noticed that this heat transfer plate I bought, the U-shaped groove is even shallower than the actual PEX. So when you put the PEX inside the grooves, the PEX will sticking out a little bit, rubbing the plywood. So I just modify those grooves to make it deeper. After I put everything down into the grooves, I use aluminum tape to secure them. And on top of that, I put another layer of vapor barrier to protect them. Now it's time to put the subfloor down. So the main point of the subfloor is I have a two-piece of a subfloor. The subfloor is cannot move like horizontally, like a back and forth, like left and right. It cannot move, but the subfloor can move vertically. That means we have to eliminate the movement up and down between these two subfloors. My solution is to cut a groove on the side of the plywood and then put or metal plate inside those grooves. So then the metal plate will secure the position of the plywood. So the two plywood will joint together. It joint into each other, so it won't move. Then exciting last step is coming. We can put the engineered hardwood floor. This is my favorite part. So the engineered floor I'm choosing is very high quality and it's very accurate, very easy to work with. The actual wood veneer part of this hardwood floor is very thick. It's about 3 millimeters. So down the road, if the hardwood floor got weared out, so you can easily sand it off the scratches and it will become new again. As you can observe, during the entire procedure of flooring project, I never used any drops of adhesive. I never used any glue to glue any layers down. Lots of people will glue every layer down to the floor and make it a whole piece, one piece. So it is good, but my floor contains 6 layers. If I use adhesive to glue them down, then I will have to spray 6 layers of adhesives. Will be lots of chemicals, lots of health concerns, lots of environment impact too. So I don't want to do that. So how I secure this floor to the van is after when I finish the floor and also I finish the cabinet on top of the floor, I will drill some holes and through our bolt all the way through the floor and secure on the frame of the van. So that's my plan. That will be secure and safely too. You have to drill some holes and openings on the floor anyways.